Hello everyone, welcome to Learn ReactJS for Frontend Development by CodeChef. When building React applications, we often create components which might look the same but don't behave the same way. For example, something which might look like a link, instead of navigating, might download a file or open a model. Or in other cases, a component might be made up of smaller parts like a header, body, and a footer. In this lesson, you will learn two useful React patterns, polymorphic components and compound components. We will understand how a component can change the HTML element rendered based on how it's called, and how we can group related components in a clean and readable way. So let's begin. In this lesson, we are learning two important React patterns. These are polymorphic components and compound components. They help us build components that are flexible, reusable, and easier to maintain. You'll often see these patterns used in UI libraries and large applications. In real applications, UI elements don't always behave the same way. Something that looks like a link might download a file or open a model. Another element might submit a form instead of navigating. So the question becomes, which HTML element should we actually use? A simple rule helps us decide. If clicking navigates to another page or section, we use an anchor tag. If clicking performs an action without changing the URL, we use a button. This rule keeps our HTML meaningful and predictable. HTML elements have built-in meaning called semantics. Screen readers and keyboards depend on these semantics. Using the wrong tag can confuse users or break keyboard navigation. Correct tags gives us accessibility and browser behavior for free. Designers may give multiple elements that look exactly the same, but their behavior is often different. Some perform actions while others navigate. So we should choose elements based on behavior and not appearance. A polymorphic component adapts based on how it's used. It can render different HTML elements internally. The styling stays the same, but the underlying tag changes. This makes components both flexible and reusable. In this example here, we build a smart link button component. If a href is provided, it renders an anchor tag. If no href is provided, it renders a button. The component chooses the correct tag automatically. An empty string is still a valid link in HTML, but empty strings are falsy in JavaScript. So simple truthy checks can cause bugs. Using type of href equal to string avoids these edge cases. In JSX, lowercase tags are treated as HTML elements. When we dynamically choose a tag, the variable must be capitalized. This tells React it's a component reference. Using a lowercase variable will cause errors. Some components naturally have multiple related parts. A modal is a good example with a header, body, and footer. We want these parts to stay grouped together, but we also want clean and readable JSX. Instead of importing many separate components, we group them under one main component. This lets us write code like modal.header and modal.body. The structure becomes easier to read and understand. In JavaScript, functions are also objects. This means we can attach properties to them. We attach header, body, and footer to the modal function. That's how modal.header actually works. But why use compound components? Compound components gives us cleaner syntax and better organization. They also reduce the number of imports needed. However, they can be confusing for beginners, so they should be used carefully and intentionally. Compound components are not the only solution. We can also export each part separately using named exports. This approach is simpler and very common. Choose the approach that fits your team and project. So the key takeaways for this lesson are that we should use the right HTML element for the right job. Polymorphic components adapt based on props. Compound components group related UI parts together. So finally, use the right HTML element for the right job. Polymorphic components adapt based on props. Compound components group related UI parts together. These patterns are common in real-world React applications. So in this given code over here, let's first understand linkButton.jsx. It accepts href, children, class name, and any extra props. These props decide how the component behaves. We are not hard-coding behavior. We are making it configurable. If href is a string, we choose an anchor tag. If not, we choose a button. This is called polymorphism. The component changes form based on props. So why type of href equal to string? We use type of instead of simple truthy check. An empty string is still a valid link in HTML. Using a truthy check could cause bugs. This makes our logic precise and reliable. Now here we render the dynamic tag. The href prop is used only if the tag is an anchor. We forward all remaining props like onClick. This makes the component flexible and reusable. Notice that the tag is capitalized. In JSX, lowercase tags are treated as HTML elements. Capitalizing tag tells React it's a dynamic component. This avoids JSX errors. Coming to app.jsx. First we'll import the link button component. Now inside the app component, we render multiple link buttons. Each one uses the same component. The difference is only in the props we pass. Now in our first link button over here, it receives a href. Because of that, it renders an anchor tag internally. Clicking it performs navigation. This follows correct HTML semantics. Now in the second link button, here we do not pass a href, so the component renders a button. Clicking it performs an action without navigation. Same UI, different behavior. Now in the third link button, it works exactly like the previous one. No href means it's a button again. The component handles the correct HTML element automatically. We don't repeat logic in app.jsx. Notice that we never manually write an a tag or button tag in app.jsx. We only describe what we want using props. The component decides the correct HTML element. This keeps our code clean, accessible and easy to maintain. If a link button receives href, it becomes a link. If it doesn't, it becomes a button. The styling stays the same, but the behavior changes. This is a practical example of polymorphic components in React. So let's just run this code once. So we can see when the app runs, we see 3 items on the screen. All 3 look the same because they share the same CSS. Visually, we cannot tell which one is a link and which one is a button. Now when I click on View Reports, the browser navigates to the reports page. This tells us that under the hood, this is rendered as an anchor tag. The URL changes, so this is navigation behavior. Now if I click on Download Invoice, it does not change the URL. Instead, it performs an action. We can see an alert. This tells us that it is rendered as a button. Now if I click on Create New Invoice, it behaves exactly like the previous one. Once again, there is no navigation, just an action. Even though this looks like a link, it behaves like a button. Now one very important observation here is that all 3 elements look identical, but their behavior is different. And we did not manually choose the a tag or button tag in app.jsx. The component made that decision for us. The behavior we just saw comes from this single line of code. If href exists, we render an anchor. If it doesn't, we render a button. That's polymorphism in action. Because we are using the correct HTML elements, screen readers and keyboards behave correctly by default. We didn't need to write extra accessibility code. Same UI, correct behavior and better accessibility. This is why polymorphic components are useful in real applications. Instead of duplicating logic, we reuse one smart component. So that's our lesson on polymorphic components and compound components. To really understand this concept, make sure to head over to the CodeChef platform and try out the practice problems yourself. That's where the real learning happens. So that was it for this lesson and I will see you in the next one. Thank you.